the main problematic is that, as we have seen just earlier, Kubernetes has its own identity system. And do you know if it is possible to use this same concept of service accounts, role, etc. on AWS? The response is no. The service account concept doesn't exist on AWS. On AWS, you use AWS IAM. And you have some components like a user, a role, etc. And basically, if you want to give access to a resource, you have to create a role, define permissions into a policy, and then you can give access to your resource to an S3 bucket, for example. So now I want to introduce you some scenario to configure permissions for applications in a Kubernetes cluster. So first scenario, you have an IAM user called Bob. He generates IAM credentials, so an access key ID and a secret access key. He wants now to give permissions to Pod to access AWS resources. So what do Bob? He sets his credentials inside the containers of the pod, or even on the EKS node where the pod is deployed. Do you think it is a good practice? No? Okay, that's the right answer. And why? Because if you put your credentials on pod, it can allow a hacker to retrieve the credentials and access freely on AWS resources based on the permissions that are configured with the user. So perfect. It was a good answer. Another scenario. So Bob took some learning courses on AWS, and he learned that a good practice is to configure instead IAM roles. And in this situation, he's telling himself, okay, so I have to give permissions to pods which are on an EKS node. So for that, he creates an IAM role for the EC2 instance inside the cluster, what we call also an instance profile. So he puts he configures a role for his EC2 instance. The EC2 instance gets temporary credentials from the role, and from that, the pod is now allowed to access to an AWS resource. Is it a good practice for you? No? And that's right. And why? Because in this kind of situation, you cannot apply a least privilege strategy. And let me explain why. So let's say you have a Kubernetes cluster. You have two kinds of applications that are running into it. For example, one only needs to read S3 objects, and another one only needs to read a DynamoDB table. And what happens when you configure a role with permissions associated to an EKS node? It happens that you successfully put permissions to access all the resources that are needed for your application, but you face some limitations. You cannot apply a least privilege strategy, because in this situation, your pod that only needs to read S3 objects will also be able to read your DynamoDB table. So this is a limitation of this strategy. And so in order to solve this problematic, yes, in order to solve this problematic, AWS released in 2019 a feature which is called IRSA, for IAM roles for service accounts. And this feature relies on OIDC, for OpenID Connect. And what is OIDC? So a quick reminder, OIDC is an open and standardized authentication and authorization protocol. It allows your application to verify user identity using an external identity provider. And for that, it is relying on a system based on GWT tokens that contains information regarding a user. And in our case, it will not be a real user, it will be a service account in the Kubernetes context. So AWS IRSA is a system to associate a service account to an IAM role, and it uses OIDC to do the link and to authorize, to do the authentication and authorization part in this system. So for that, you have to create an OIDC provider dedicated for your Kubernetes cluster so that you can authenticate and authorize your service account. Of course, as a prerequisite, you also need to configure an IAM role so that your pod will have the appropriate permissions to access an AWS resource. And one additional thing to configure is a role trust policy. So a quick reminder, a role trust policy allows you to control which entity can assume an IAM role. And so in our case, we want to be sure that only a dedicated service account in our Kubernetes cluster can assume this role. So let's take a trust policy here. So there are multiple sections in this policy. So for this first section, which is called the principal section, it is used to define which entity will have the ability to perform the assume role action on the IAM role. And in our case, we will set up the cluster OIDC provider, which is set up for our Kubernetes cluster. So for the action, we allow to do the assume role with web identity. And if we want to control that only a specific service account in a specific namespace can assume this role, we can add a condition for that, where we can set up the namespace and the service account. And another step to configure, but more on the Kubernetes side, is adding what we call an annotation in on your service account that will be used for your pod. So there are two kinds of process to set up this system. One on AWS with all the policy, trust policy, etc. Resources to configure, and on Kubernetes you have to add an annotations on a service account. So it can provide some challenges to automate all these things. So at the end, we are in this kind of setup where you have your application that needs to access through an AWS resource, like an S3 bucket in this example. So you have to create a service account, and this service account has to be authorized to assume the dedicated IAM role thanks to an OIDC provider that has to be set up. And once all this setup is done, your application can access this S3 bucket. However, this system works very well, but AWS received some feedbacks regarding some limitations. in some situation, generally in large company, you may have some actions that can be restricted. So let's say that you are working in a development or an operation team, and you don't have access to configure OIDC providers because maybe it is managed by the security team or something like this. Or even you cannot update IAM trust policy. So it can be problematic in this case. You have to maybe raise a ticket, contact security team. There is some delay, so it can be a bit frustrating. There is also another limitation, which is every time I want to allow a service account to assume a role, I have to update the trust policy and add for each service account in each namespace a specific line. And if you are doing some deployment process like blue-green, it can be really painful as you every time have to update this trust policy. There is a hard limit on AWS on an AWS account, which is the number of OIDC providers. So if you are working in a company where you have to set up a lot of Kubernetes clusters, you cannot exceed 100 because you cannot have more than 100 OIDC providers. And finally, another limitation is about the size of the trust policies. It is limited to 4,090 60 characters. So if you have a lot of service accounts, a lot of namespaces, and a lot of pods that want to use the same role, it will be a limitation for that. And so by hearing all these feedbacks from customers, AWS worked on a new feature called EKS Pod Identity to solve this kind of limitations. So to deep dive a bit on how it works, let's take this scenario. So first, we create a new kind of resource which is called a pod association. So basically, a pod association allows you to do the mapping between a service account, a cluster, and the role that you want your pod to associate. And for that, you have to first deploy an add-on called a pod identity agent. And once you have installed this, every time you create a new pod in your cluster, there is an EKS Pod Identity webhook, which is managed on the control plane, which is triggered. And when it is triggered, it applies pod mutation. So a mutation is some configuration that are added to your pod at your creation. So it injects some environment variables inside your container in order to specify something like what is the IP address of the agent that is running in your cluster, or even where is the location of the service account that is present in your pod. So you created your application, and now the agent has permissions to get IAM credentials for your application. So it will retrieve the service account token which is in your pod, and it will try to check if it is validated enough to be able to retrieve IAM credentials. So there are some steps for that. So first, the agent performs an assume role for pod identity action on an EKS Auth API. The EKS Auth API will then check if there is a pod association between your pod and the targeted IAM role. So it will see if the pod is associated to the correct service account, to the correct cluster. And then, if it is OK, pod identity agent will provide the IAM credentials to your application, to your pod, and then your pod will be able to access to your AWS resource. So, to do a quick recap on this feature, at first you have to install a pod identity agent add-on on your EKS cluster. You have to create a pod association to associate your pod to your cluster to a service account. Thanks to this system, now your trust policy is simplified. Let's take a quick example for that. So this is what look like a trust policy with IRSA, the previous method that I showed you. And now we are going on this kind of policy. You see the size of the trust policy has reduced of size. And now we are introducing a new service principle, which is called pods EKS Amazon AWS.com, which allows you to be sure that only a pod using pod identity feature can be allowed to assume a role. And so for the action, of course, we are setting that we want our pod to assume the role, but also we have to set up another permission, which is called taxation. And you will ask why. The answer is quite simple. It's because with EKS pod identity, we can now rely on session tags to have a better control, to have fine-grained permissions in order to reuse a role for different pods. On the infrastructure as code aspect, I took an example of a Terraform configuration. So when you create a pod association, you have to specify the cluster name, the namespace where your application is running, and the service account. So we can see in this example that we don't have to add an annotation on your service account on Kubernetes. All is defined in this resource, and it can be easily automated with Terraform or even CloudFormation if you want. So as I said earlier, session tags are introduced here with this feature to allow you to control what pods on different clusters, namespaces, and service accounts can assume the same role. So in order to illustrate this feature, I propose you this scenario where you have two applications that are running on two different Kubernetes clusters. They all want to access objects inside an S3 bucket. So we define an IAM role that will have the permission set to allow to allow access on S3 bucket on this bucket. But we can go even deeper on the fine-grained permissions configurations for that. We can say maybe I want my Kubernetes pod to access to specific objects based on the cluster name where my pod is deployed. So maybe I would say, okay, I have some objects. I only want this object to be accessible from cluster A, for example. You can use this kind of session tags in a policy to have this fine-grained permission to be set up. So that's the end of the presentation. Some key takeaways to retain from this session. So avoid as much as possible to hard code credentials on pods or nodes. Avoid also to associate an identity directly to an instance profile, an IAM role dedicated for your node. And instead, consider using a feature like EKS Pod Identity to have flexible and granular access control. You will benefit from that feature to have a more simplified infrastructure as code configuration with Terraform or CloudFormation, for example. And it will allow you also to have a simple and a fine-grained controls for reusing multiple, the same role for multiple clusters, namespaces, and service accounts by using those session tags that I just show you up. And that's the end of this session. So if you have any question, I will be pleased to ask, respond. Okay.
Yeah, pretty good presentation.
Thank you.
Thank you for it. I had a basic question around like, can you create user groups by specifying policy on the group and then like make sure that there's maybe a policy stating that this user group can access this pod and like maybe assign those policies on like a particular pod or a cluster?
Okay. So in AWS IAM, you can create user groups, but it contains only users.
Oh, okay.
And in our situation, we better think of using IAM role in order to have temporary credentials and to restrict access to specific service like EKS pods by using the service principal pods.eks.amazon.aws.com. So we better use this method instead of creating users or even put them in groups and associate policies.
So, roles?
Yes.
Thank you.
You're welcome. I think there was a question just behind you.
Actually, mine is on a different but related topic.
Okay, okay. Thanks. I think that we are done. Thank you for your attention.